Hello, everybody. Welcome to Tuesday, March 23rd, 2021. Mr. Parrott here with your rundown of what we're doing in class today. First and foremost, make sure that you answer up the bell ringer. Secondly, we're going to do a little lab activity today involving gene frequencies and seeing whether or not dominant or recessive will win out in our environment today. So, without further ado, we're just going to open up with the gene frequencies and bunnies. Because what we got is, in this activity, you will examine natural selection in a small population of wild rabbits. Natural selection on a genetic level is a change in the frequency of alleles in a population over a period of time, meaning that there's going to be a change in whether or not there is more recessive or more dominant alleles in that species. They'll switch one way or another. Breeders of rabbits have long been familiar with the variety of genetic traits that affect the survivability of rabbits in the wild as well as in the breeding populations for pets. One such trait is having fur or not having fur, making furless bunnies, aka naked bunnies. This trait was first discovered in England by W.E. Castle in 1933, and the furless rabbit is rarely found in the wild because of the fact that they end up freezing over the long, cold winter months there. So we've got our two different types of bunnies. You got your traditional bunny, as you can see over there to the left, and then right smack dab in the middle is going to be our furless rabbit, so you didn't think I was making this stuff up. That's what the trait would look like if they do not have the fur coating to them. Say, furless bunny. And in today's activity, to represent the alleles, we're going to have bunnies that are big A, and big A, little a that have fur, and bunnies that inherit the little a characteristic will have no fur. And we're going to be using beans to represent our lab. So what you'll need to do is go through that introduction again, answer up these 4 questions about that introduction. You're going to create a hypothesis of what type of bunny you think is going to survive in our activity, whether it is the furless or furry bunnies, and why. And then here's the things that we'll need for the lab. In our lab, we're going to be using beans. Here's a bean right here. It's a red bean. This is going to represent dominance. We'll have white beans representing recessive. We've got, in this case, the Pringles can representing our wonderful English countryside, where the rabbits meet, breed, and reproduce. We have then 3 cups. One is labeled, you can see it, big A. One is labeled big A, and one is labeled little. And that's basically because how the lab's going to work. And I'm going to show you how it works before I show you the data that you're going to be using. So what happens is that there's 50 of each type of beans in this container. Without looking, you're going to draw 2 beans out at a time. So in this case, I got 2 reds. That's a big A. I'm going to put that in the big A cup. I'm going to draw another combination. This one's a big and a little. I would put that in the big and little cup. And for the last one, I'm going to force this to happen. You'd be doing it randomly. I got 2 whites. The whites would go into little a, because those represent the furless bunnies. I'm going to do that until all 100 beans are out of the containers and are in one of these cups. And I'm just going to simply put down how many bunnies I got for each type in the box here. We then have to decide on what bunnies live and what bunnies die. The little bunnies are born furless. The cold weather kills half of them before they reproduce. So what you're going to do is you're going to take half of your beans that are in this cup and you are going to kill them off. For today's activity, you're going to just put them to the side. They do not return back to the population. So you're going to put down how many big A alleles you have left. They're not going to be used the rest of the stuff here. The dominant ones live. So you write down how many dominant ones, how many big A dominants that you have. Remember, there's 2 for every red. And then how many little a's are left, because in the big A, little a, remember you'd have some little a's. So we are tracking down those bunnies. And then it's time to figure out gene frequency. How we figure out gene frequency? We look at the total number of alleles for both the big A and the little a. And in this case, your gene frequency is that you take the number of big A alleles divided by the number of big A plus little a alleles. You're going to multiply that number by 100 to get you some kind of percentage. That is the frequency of how often that is said to be dominant versus recessive in that population. And then you'll repeat it with the next generation, do the same thing, and then the next generation for the third thing. Then you're done. Then there's some questions to answer at the end based off of the activity. Now, because you do not have my lovely container full of beans, here's what you need to do. I have created already, see if I can find it here, in the folder, a QL Learner bunny gene frequency data for you. So when you pull up this data, here's what it'll be. I've got them broken up by their rabbits by generation, the number of alleles per generation, and then the total number of alleles in those generations, so that you can jot those numbers into your slideshow, and then you need to calculate specifically gene frequency yourself. So you'll have to do the addition and dividing and multiplying by those things, but all of these are here, and I tell you what specific slide these numbers go along with. So it'll say slide number 6, for example. That would be back on this, slide number 6, or slide number 6. So you'd put that information for generation 1 on slide 6, where it would appropriately go. Make sure you're checking to look at to see what things are what. They should be in the similar order, but double check just to make sure. Next set has to do with just the allele. So there's a slide 7 one, and then there's 2 for slide 8. And then we have slide 9, which you'll use this whole entire row and help you to calculate out gene frequencies. The only thing that you are not going to have a box for, because I just graciously did this math for you, you do not have just a box to put down the total number of alleles. There's only a box for the number of little a's and the number of big A's. I went ahead and gave you the total number. That is what you have to divide by. So like, for example, this first one would be 42 divided by 92. I'm not going to tell you what the answer is, but you punch that into your calculator. It'll give you something. You then times that answer by 100. That gives you your percentage. Feel free to round the percentage. So if it is 0.5 or higher, round it up. If it's 0.4 or lower, round it down, your usual stuff there. And that's how you're going to be able to complete our lab, because you're not going to be able to pick what bunnies are going to be born with their genes in here or not. You'll have to go off of our data and just be interpreting the data at that point. So that's what we're doing today. If you have any questions whatsoever about what we're doing, do not hesitate to email me. But if not, hope you're doing well, staying safe. Hope that I'll see you before spring break happens. So I hope to see you by the end of the week. But if not, check out tomorrow's video, and I'll see you later. Bye.